Hello everyone and welcome to another demonstration. Today I, Greg Zoll, will be showing you how to use Red Hat Satellite, which is their lifecycle management system, to provision machines out in Azure. So once those VMs are provisioned, Azure will use a method called Callback to connect back into the Ansible automation platform so they can do all the post-provision works. So the idea being is I can have a golden image for RHEL, and I don't have to customize it per the individual use, because I will just deploy that golden image, and then once it calls the Ansible automation platform, that will actually say, okay, you're a web server, do the web server configuration, or you're a database server, do the database server additional configurations, right? So it gives you a lot more flexibility, because making new images for all of your different things can be tedious, and this keeps it simple. So first things first, you're gonna have to install Satellite, and you're going to have to get your Azure environment ready. So in my blog post on this, the blog post is pretty lengthy because I start from scratch. So I've actually got some playbooks in there that show you doing deployment of your Satellite, and as well as kind of some of the basic initial configuration. Same thing for your Azure environment. I've actually got some playbooks in there that will allow you to just automatically provision your Azure environment. So you can really get it kind of up to speed on this from zero pretty quickly. Now, having said that, I'm not configuring a lot of the bells and whistles, a lot of the features and functionality that you would really be using Satellite for. This is really just more for demonstration purposes to show you how that integration between Satellite to Azure, Azure to Ansible automation platform kind of comes together. So, having said that, the first thing you're going to do is you're going to configure your Azure connection in between your Satellite server and Azure itself. So generally you do that from infrastructure, compute resources. You come in here, you configure your Azure connection. So one thing of note is whenever you're creating this compute resource, it gives you the option to choose the region you want this to come from, right? Is it going to be, East US? Is it going to be South Central? And so keep in mind that not all resources are available in all regions, right? So if I choose South Central and I'm trying to deploy maybe a specific RHEL image, it's probably not going to be there. So for my environment, I chose to have it be in East US because virtually everything is available there, so I didn't have to think about it. And so you could theoretically create multiple compute resources, right? So whenever I say that this compute resource is in East US, everything I provision through this will always be in East US. I can't alternately say, oh, some things are going to be in South Central or some are going to be in West. Everything's going to be through East US. So if I wanted to have also from all this same account information, be able to provision a different region, I could just create additional compute resource and then choose the specific region I want that resource to be provisioned in. So that's just, it's not really a gotcha, it's just something to make note of. So everything that I'm going to provision via Azure Personal will again come from, East US region. So once you do that, you're going to want to add some images in here. So images can actually be looked up on Azure, but really I'm just going with the latest RHEL 7. You're probably going to want to standardize on a specific version, right? For version controlling, that's entirely up to you. Something that I don't know why it got me, because it's right there in the documentation, but whenever you're creating an image, or you're adding an image, don't just put in the image name. You actually have to add marketplace : // If I could just read the documentation, it would have saved me like 15 minutes of trying to figure out what I did wrong there. But also whenever you're adding these compute resources, you want to set up a username and password. You don't want it to be root. Azure doesn't like it when you try and use the root username. So I put Ansible in there for all of mine because I'm going to have the Ansible automation platform actually connect in and do all the configuration. So keep that in mind. Once you do have an image in place, you're going to want to go to compute profiles, and by default it's going to add these three: small, medium, and large. I only configured the small because, again, this is just a lab environment. And so I really just want to show this functionality. So in here, I'm going to choose the resource group from Azure. And that was actually pre-populated from my playbook that I ran. That's available in the GitHub. Just check the blog post. It's got all the good stuff in there. But for this RHEL 7 image, they recommend the standard D2S_v3 Linux platform. Again, username and password I'm setting up in there. Let's see what else. Custom scripts. I'll come back to this momentarily. But for now, just remember that this is really what makes all the magic happen. After that, I'm going to do the network interfaces, and my custom setup script actually creates a subnet in there that you can pull from. And then you're going to want to add a storage device, give it some size, and then submit, and that'll save it. And that storage profile is there ready to go. I'm now going to take a look at my tower server, or my Ansible automation platform controller. Whichever version you're utilizing, you're going to know it as something different. So first things first, I actually have to pull in Ansible Satellite's inventory into my server, right? It's going to be a custom inventory. But first things first, you actually have to create a credential. So for that, I hit the plus, I add in my credential information, and when I select credential type, I'm going to look for SAT for satellite. I'm going to choose Red Hat Satellite 6. And when I do that, it gives me some additional options, right? So I'm going to name it as per. I'm going to put in the default organization, but then I'm going to give it the URL of my satellite server, and mine is satellite2.gregsole.com. I'm going to give it the username and password that's going to be able to log in and connect to those inventory sources. So I've already added that in for myself. It's just Ansible satellite 2. And then I'm going to go to my inventories, and I'm going to create a standard inventory. So in this case, I've got satellite 2 right here already set up. So I'll give it a name. I'll click save. Once I click save, it gives me the option to go to sources. Once I do that, I hit the plus, and I will add a new inventory source, and I'm just naming it satellite2.gregsole.com because that's the server, the satellite server that it's connecting to. When I select source, Red Hat Satellite 6, it gives me some additional options. Here, credential. And this is really what does all the work, right? So in credential, remember, we put in the URL of the server, username and password. And so when I specify the satellite 2 server, it's going to connect in there and be able to pull all that information. So now that I've done that, I want to add these update options. And so this is going to give it the ability that if there is an inventory object and it gets modified, it's going to overwrite it. It's really going to also delete any inventory objects that are in my Ansible automation platform inventory that don't exist in satellite anymore. It's going to get rid of those from this. And then also update on launch, which means anytime this inventory source is accessed, it'll go ahead and fire off this lookup, right? So it'll always be fresh. So anytime somebody wants to query this inventory, I'm always going to have the freshest information in here. So what a lot of folks do with their satellite servers is they configure them to also act as DNS servers. So once you provision something via satellite, it'll create a DNS entry for it as well as a reverse, and that works great because whenever it adds hosts in, it puts their device name as their fully qualified domain name. But in my lab environment, I didn't want to utilize DNS, or maybe in your production for whatever reason you don't want it to automatically register all that stuff with DNS. Well, how do you get around that? Because part of the callback functionality is it actually has to exist in an inventory before the callback functionality will work. So if I have a server and I issue a callback command, which really calls my tower server, and it's not in whatever inventory that job template happens to live in, it's going to throw an error. So what you can do is use the compose option. So whenever I query satellite 6, it's foreman on the back end. And so everything gets added in as foreman underscore something, right? I'm going to pop in here and take a look at the hosts. I can see I've got one host in here. I'm going to go ahead and expand it. And you can see by default, it's got all of these various options in here, right? That are all foreman underscore something. And that's not super usable because Ansible Tower doesn't understand what foreman underscore is, right? It just knows that they're variables, but it can't actually use them. So in here, there is foreman underscore IP, which is ultimately what I want because this is the IP of the virtual machine that I want to connect into to configure. But again, the Ansible automation platform doesn't understand what that is. So I can use the compose command. So if I use compose : and then under here I can put a variable which is Ansible _ host. And so that's a magic variable inside of the Ansible automation platform that says, hey, if the host name that I've supplied isn't a fully qualified domain name, use Ansible _ host to connect to it, right? So generally that'll be the IP address of the device you want to connect to. So foreman IP is one of the variables passed over from satellite. So I'm just saying, hey, when foreman IP comes over, set it to Ansible _ host. And again, if I pop back over here, I look, the very first variable in the list is Ansible _ host because that compose command created it. So now when I do the callback from the virtual machine, it's going to show up. It's in the inventory. It's going to see Ansible _ host. Bob's your uncle. Everything's going to function properly. So that's just one of the little secret tidbits I had to add in to get everything to function properly. So now that we've got the satellite inventory in there, I can actually, in the sources section, I can hit the synchronize button and it will synchronize. It'll pull all of the inventory items in. Right now I don't really have anything because I've got my satellite server nulled back out. I'm actually going to add a job template in for the Azure services. And I named it, I've got one testing box and another testing box here, and so satellite 2 is my second one. So I just called it Azure VM callback because that's exactly what it is. It's a Azure virtual machine and it's doing a callback. So in here, I'm going to do all the normal stuff. I'm going to specify where it's coming from, the project it's supplied from. I have the Azure virtual machine prep playbook in there. And again, this is my public Git repository and I'll show it just in a second. For credentials in my satellite server, whenever I set everything up, I just use the Ansible user, remember? And so I added an Ansible user in here. I just went and created a credential for it, gave it the correct username and password, and then added it here. And then I do provisioning callbacks. So you hit the checkbox here for enable provisioning callback, and it automatically gives you the URL here as well as a host config key, and that is more or less like a password that allows it to call this specific job template. You can hit the refresh button there and it'll just give you a new host key. You can also, if you want to see the exact curl command you would normally enter, you can hit the question mark there and it'll pop it up, right? And I can copy and paste this into any server with that curl command, and it will actually do the call. And so ultimately that's what I'm going to be putting into my satellite server here momentarily to do the work. So now that I've got this job template done, I can just click save and I'm actually done with that portion. Now that I've mentioned it, I'm going to pop into my Git repository. I'm going to take a look at it and just kind of walk you through the little steps because I had to actually trial and error this and there's some specialized stuff in here. So really it looks like just kind of a standard playbook. First things first, whenever you're doing a callback, it's going to connect to the device and it's going to store its key, right? So the IP address is going to store the SSH key in varlib awx.ssh known hosts. It doesn't do this whenever you're doing standard Ansible controller things. It's just whenever you're doing a callback. And so in my lab environment, I'm building up and tearing down constantly over and over, so it's reusing the same IP addressing over and over. And if it sees a host key already in there for that IP address, it's going to brick and break your playbook. So here I'm just looking for, hey, does that IP address match an SSH key that already exists? If it does, go ahead and remove that. Next, it's going to move over and I'm just having it do a message of the day. This is a way for me to, in my lab environment, I can log into the VM really quick and I can immediately see, yeah, all this stuff ran just fine. Although I can, automatically do that from Tower if I see everything complete. Next, I'm going to be setting fully qualified domain name on the box. I'm then going to download the Catello RPM, right? So this is going to be coming straight from my satellite server. So you're going to want to modify this to match what your satellite server is. It's going to connect in and pull that. Next, it's going to install it. After that, it's going to do another little hack that was required inside of the Azure environment. So by default, whenever you provision a new resource group, or perhaps it's on subscription, I can't recall right off the top of my head, but it creates this randomized domain name .cloudapp.net, right? And so that you can kind of uniquely access your resources. Well, whenever you're going to do the subscription manager register command over to your satellite server right from the virtual machine, it's going to have that crazy network name of whatever it is .cloudapp.net instead of using my Greg Soul domain, right? I could go in and I could configure Azure, I believe, to have all that domain information, but I didn't want to do all that tying together. So to work around that, I can, in this directory, I can create a catello.fax file, and I can specify what I want the variables to be instead of to dynamically discover them. Network.fullyqualified domain name, I'm setting it to the inventory, so it'll be whatever the server name is .gregsoul.com. Now, whenever I issue this next subscription manager register command, it'll show back up as the proper fully qualified domain name. So prior to this, whenever you provision a machine, it'll show up in the list here. If I go to content hosts, and I go to content host, it would show up in the list as the provision name .gregsoul.com, and then when it actually registered back, it would be provision name that crazy domain name from Azure, right? So it just wasn't working right. It was showing multiple entries for all this stuff, so I was having a very bad time. So by setting this network fully qualified domain name in the Catello file, then when I issue the register, it calls back and actually properly registers the entry of the device that was provisioned. Last, I'm just doing some standard satellite tool install, and then I'm doing the RPM install for them. So at this point, I could actually, and I probably would in my environment, have a logic tree after this. So I would say, if it is in host group web, then I would call a playbook and perform all the web server actions. Or I could call a job workflow, right? And I could perform multiple actions after that. Or, so I could say, hey, if you're in the web group, perform all these other actions, right? And so generally I'm going to keep those in a different file or a different workflow. And then after that, I could say, hey, if you're in the database group, perform these other jobs or these other workflows. Or instead of looking for groups, because whatever host group I configure in satellite actually gets passed over as a foreman underscore variable, I could also just look at the name of the server. So I could, there's www in it, I know it's a web server, do all the web server post configuration. If there's DB in the name, right? So it's just, it's kind of however you want to do that, but it gives you additional functionality to really build out those environment pieces. I will come into my satellite server, and in the infrastructure compute profile, small, I come into this one, I'm going to add the callback in here for custom script. So in Tower, under the job template, or rather the Ansible automation platform, controller, Tower, whichever you're using, the copy and paste, that's it right here. Just copy and paste right on that line and you're good. But there's more to it, all right? You can see I have more in this command. So what this does is satellite will connect to your host once it's provisioned the VM, and it'll throw this command at it, and then it closes out. By default, whenever it does the callback command, it's going to synchronize the inventory. Remember, that's the very first thing that the Ansible automation platform is going to do. And if I do that too quickly, this host won't actually live in the satellite database. So it'll come up empty, and then the callback will fail because this device isn't in the inventory. So what I do is I throw a sleep command at it, right? So I say sleep for 45 seconds. Basically just wait 45 seconds. That gives it a little bit of extra time. After that, then I do the curl command so that it will now do the callback. The only problem with this is if I just issue this, it'll actually terminate too fast, because the SSH session will just kill itself really quick and it doesn't, properly complete everything. So what you want to do is add no hup, which will tell it, hey, run all this stuff sans terminal, and then I'm going to throw it in the background as well with this last ampersand. So it will do all this in the background, disconnected from the satellite server, and everything will work just great. Once you save that to your compute resource, you're going to want to create a host group. So configure host groups where you kind of have the ability to pre-populate everything. I just named one default to be lazy. So again, lifecycle environment, you're going to want to do more than just library. You're going to actually have, like testing, development, production, all of those good things. But for my lab environment, just to be lazy, I went ahead and used library, which is more or less the catch-all. Interesting pieces is, or rather are, deploy on. Here's the Azure personal. That's the good piece. So that's going to tell it to deploy out in the Azure cloud. And I chose my compute profile, which is small. It's the only one that I've configured. Add all of your default options in here. Don't forget to add a domain name, because it'll barf on that as well. Operating system, any additional information you can kind of put in here ahead of time, right, is going to save you time. So you're going to want to head and go in and fill all this good stuff out. So once you click submit, you've got everything saved in there. I'm going to go to hosts. I'm going to create a host. So this is where it's actually going to reach out and deploy all this stuff in Azure. So I'm going to choose my host group, and it will pre-populate everything for me. It just takes a second. I'm going to pop over to virtual machine once it appears. Here it is, and you can see that it's got all the custom scripting I need. It's got all the username and password information still stored in here. I'm going to go to operating system. I'm going to choose RHEL 7. I'm going to give it a root password. I'm going to click submit. So really, once you have everything kind of configured in the system, all you have to do is create new hosts, choose the right host template, and choose the operating system. After that, you just wait on it to complete. I'm going to kick back over to jobs in my satellite server, or rather in my Ansible automation platform, and I see that the inventory just did a synchronization, and now I see it running the VM callback job template. Enter that job template, and I can watch it as everything provisions. All right, now that it's completed, I see that it's walked through all the steps, and this one in particular registered the system with satellite server. So I should be able to pop back over to my satellite, go to host, content host, and if everything worked correctly, I see, what is that, Lori Josic? Satellite comes up with some interesting randomized names, but I see the important bits here is registered and last check-in, so that it actually did complete all of the post-configuration operations. So again, this is a cool way to allow the Ansible automation platform to really do all of your post-provisioning. So you can do some very complex workflows if you want to, or you can just keep it simple. So for like me, where I just did those RPMs, did some standard patching, you could do your boilerplate. This is what my default hardening guide looks like. It's really easy to throw all that stuff in there. So I guess if you guys have any questions or comments, I would be really curious to hear them. Obviously, no way I ever do things is 100% the best, fastest, most optimal. So if you know of a better way, let me know. Thanks, and we'll see you next time.